Okay, today we're going to be looking at the test review that is posted on Canvas. So the first two problems are simplifying problems, as for 1 and 2. Simplify expressions by combining like terms. I don't know why it says hard next to it. So we have negative 5x, and then 2x minus 1, minus x, minus 4x squared. Okay, so we know that there are two steps to simplifying. The first step is to distribute. That's the first step. So if we see any parentheses, we will distribute. We, of course, see parentheses here, so we will distribute. Negative 5 times 2, negative 10. X times x is x to the second power. Negative 5 times negative 1 is positive 5, and there's no x, so it's just x. So this becomes negative 10x squared plus 5x. And then we still have minus x, and we still have minus 4x squared. So distribution has been completed, and we move on to combining like terms. So we're going to be looking for terms that have the same variable and exponent. So these two would be considered like terms because even though the number is different, negative 10 and negative 4, the variable x is the same and the exponent 2 is the same. So this would be called a x squared term. So I just combine negative 10 minus 4 is negative 14. So this is negative 14x squared. Those combine to make negative 14x squared. Now these are x terms. I have positive 5x and I have negative 1x. Remember, there's 1 here. So this is going to make an x term. 5 minus 1 is positive 4, so we get plus 4x. And here we have our simplified expression because everything has been distributed and like terms have been combined. So negative 14x squared plus 4x. Number 2, we have 12c minus 3 minus 2c minus 13. We are trying to simplify this expression. Remember, this is not an equation. There's no equal sign. This is just an expression. So first we want to distribute, but we see there's no parentheses anywhere in the problem. So we're going to move on to combining like terms. So we got 12c and negative 2c. These are a c term. So 12c, negative 2c, so 12 minus 2 is 10, and it's still a c term. So those two combine to create that. Next we have negative 3 and negative 13. Those are constant terms. We just add those. Negative 3 minus 13 is negative 16. So this represents our simplified expression. Okay, there's no like terms anymore, and there's no parentheses. Number 3 asks us to solve the equation. So we're given an equation, 4x minus 2 equals 18 minus 10x. We're given an equation, we're asked to solve it. So solving it would mean getting the x by itself. Okay, we want to know what x is. What x value will evaluate the left side and the right side and make them equal to each other. So first we check each side to see if it's simplified. So 4x minus 2, of course that is simplified because there's no parentheses, there's no like terms, so that's simplified. And the other side is simplified as well, 18 minus 10x. So both sides are simplified. We can move on to the second step, which is putting the x's on one side. Okay, so on the left side. So we're going to look on the right side. On the right side, we see two terms. We see this one and this one. And this term has an x in it. The negative 10x has an x in it. And that's not okay. We need that on the left side. So I'm going to move that to the left side by adding or subtracting. It's already subtracted, so I'm going to add it to get it to the left side. Okay, I'm going to add it over here. Okay, what this does is it allows me to move this negative 10x to the right side and combine it with the x that's already there. So I have 4x plus 10x, 14x, and then everything else, minus 2 equals, and then 18, but the 10x and minus 10x on this side, they cancel out. At this point, I now have the x on the left-hand side, and the only thing on the right-hand side is 18. So I can now begin to solve this for x. Okay, so remember, before you can touch the 14x, it has to be the only thing over there. Right now, minus 2 is over there as well, so that is going to have to go before I can touch this. So I'm going to add 2 to get rid of it. So I got 14x is equal to 20. Now I'm getting closer to having this x by itself. The only thing that's left is to get rid of the 14. And since it's the only term, now I am allowed to touch it, and I can get rid of the 14. It's being multiplied, so I can divide. X is equal to 20 over 14. And of course, I would want to simplify, reduce that, make that a reduced fraction. So they're both divisible by 2. 2 goes into 20 10 times, and 2 goes into 14 7 times. So that reduces to 10 over 7. And that is my solution. That is the number that makes both sides into the same. It evaluates both sides to the same. Number 4, we're still solving with 2x plus 5 minus 4x equals 3 times 1 minus x. So the first thing here is to check to make sure both sides are simplified. When I look at the left side, this is clearly not simplified because I have like terms. There's no distribution, but I do have like terms. The like terms here would be the 2x and the negative 4x. When I combine those, 2 minus 4 gives me negative 2x. And then the plus 5 is the same. The right side is also not simplified because I need to distribute. I have parentheses, so I need to distribute. So if I distribute, 3 times 1 is 3. 3 times negative x, remember this is a negative 1x, so 3 times negative 1 is negative 3x. Okay, so now both sides are simplified. The left side is simplified, the right side is simplified. Now I need to check to make sure the x is only on the left side. There's an x on the left side, however there's also an x on the right side. This x on the right side is going to have to move to the left side. Just like in the previous problem, I can accomplish that by adding it. Okay, because adding it to the negative will cancel it out because it will make 0. Over here, negative 2x plus 3x is just 1x, or just x. I don't have to put the 1 here. So it's just x, and then plus 5 equals 3. And at this point, it's pretty easy to solve for the x now, because the only thing over there with the x is the plus 5. So I can get rid of the plus 5 by subtracting it. And I get my solution, x equals negative 2. This should be the number that causes both sides to be the same. Number 5. Number 5 is a literal equation. It says, consider the literal equation I equals PRT. And we want to solve this literal equation for t. We want to solve this for t. So first we identify t. T is right here. And it's on the right side of the equation. Now, there's only one term on the right side, this PRT. That's the only thing, it's the only term on the right-hand side. There's no additional terms over here that I have to move to the left side. So I know that I'm only going to be doing division here, because these are all together in one term. So I just need to divide by what I would like to get rid of here. I would like to get rid of the P, I would like to get rid of the R. So I'm going to divide both sides by the P and the R. And that's going to get rid of the P, it's going to get rid of the R. So I end up with I over PR is equal to T. This is now solved for T because T is alone on the right-hand side. Now on the test, you might see it the other way around. You might see it T equals I over PR. Okay, it's the same thing, okay? It's just been switched around. Typically, we put the variable that's by itself on the left-hand side. So it might be written like this. Number 6, we have y is equal to mx plus b, and this is being solved for x. Okay, so when we look at where the x is on the right-hand side. Now, there are two terms on the right-hand side. Okay, there's this mx term, and there's this b term. Well, we cannot touch this mx term until this b term is gone. Okay, so this b term is going to have to go to the other side. And I can do that by subtracting it because it's being added, and that will get rid of the b term on the right hand side. And that would just leave me with y minus b equals mx. Okay, so now the term in question is by itself. The term with the x is by itself. So I can now start messing with it. And I need to get rid of the m. The m is being multiplied, so I will divide it because m over m becomes 1. So I got y minus b over m equals x. And this would be solved for x because x is, of course, by itself. Now for this next one, let me bring over, we need to actually look at the graph here. Okay, so it says find the average rate of change when t equals 50 seconds to when t equals 70 seconds. So remember what average rate of change is. That's change in something else over change in some, it's change in something over change in something. And this, it's always change in y over change in x. Well, if we look at the graph here, this is the x-axis, this is the y-axis. So what we're actually considering here is the change in the distance over the change in the time, okay? So when 50 seconds, so 50 seconds, we have to look for 50 seconds. 50 seconds is right here. The distance is 100 meters. Okay, so this is the ordered pair 50, 100. So at 50 seconds, the distance is 100 meters. Now we also need another point, and that's going to be at 70 seconds. So if we look at 70 seconds, which is right here, then that puts us here. So at 70 seconds, we are at 40 meters. Okay, so we want to know the rate of change from this point to this point. It's going to be the slope of this line segment between them. Okay, we see this line segment. It's going to be the slope between them. Now this is going down, so our rate of change here is going to be negative. Okay, so the change in the distance, or the change in y, let's start there. So the change in the distance, we start at 100 distance, and we end at 40 distance. So that is actually us going down by 60 meters. Okay, so that would be negative 60 meters. Negative 60 meters, because we're going down by 60. Now the time, we're going from 50 seconds to 70 seconds. So that's 20 seconds. From 50 seconds to 70 seconds, that's 20 seconds. So we can see the rise and run. We don't even have to do the formula. We can see from the graph what the change in the distance is and what the change in the time is. So that's 20 seconds. You'll notice that I'm keeping it negative here because it's going down. So my rate of change will be negative. Now I'm just going to simplify this. 60 over 20 is 3. So this is negative 3 or negative 3 over 1. I'm just going to leave it as negative 3. And the units here, remember, we're changing distance over time. So I'm moving negative 3 meters per second. Okay, that's what this m was, that's meters, and this is seconds. Okay, 20 seconds, 60 meters. So negative 3 meters per second, or you could say negative 3 over 1 meters per second. Either one is fine. Okay, number 8, well, I guess we're going to have to use the page for this as well, since it's a graph. Okay, number 8 says that we are trying to write the equation in slope-intercept form, then graph it. Okay, so slope-intercept form means to solve this for the y. It needs to be solved for the y. So that means that the x needs to go to the other side, because on the left-hand side there's two terms, this one and this one. And if we want to get this term by itself, this term needs to go. So I end up with negative 2y is equal to negative 4x minus 8. And I'm writing it that way so that it is in slope-intercept form, y equals mx plus b. So the x will come first, the b will come after. And then I need to get rid of this -2, so I will divide, and I'll divide all of these by -2. And that leaves me something like this. So -4 over -2 is +2, so 2x. And -8 over -2 is +4. So that's my slope-intercept form right here, 2x plus 1. That means my y-intercept is 0, 4, and my slope is 2, or 2 over 1. Okay, so my graph's going to look something like, and remember that's a positive slope, so this is going to be pointing upwards. So 0, 4 is right here, up 2 and over 1, or I could go down 2 and over 1. As long as it's pointing up, it doesn't really matter. Okay, so I'm going to connect these. Okay, so this is my line right here. The domain of this line, remember the domain refers to the x-coordinates, and we can see every point on this line, the x-coordinate is anything. Any x-coordinate is fine, so this is all real numbers. And the range of this is also all real numbers because this graph extends up forever and it extends down forever. So the range is also all real numbers. Now the y-intercept here is pretty easy. We already have it. It's the point 0, 4. The x-intercept, however, we need to find that by plugging in 0 for the y-coordinate. Y-intercept is always 0 for the x-coordinate. X-intercept is always 0 for the y-coordinate. So I'm going to go back to one of my equations. I'm actually going to go back, I could use this, actually I'll just use this one, y equals 2x plus 4. And I'm going to plug in 0 for the y-coordinate. So 0 equals 2x plus 4. So 0 for the y-coordinate. If I solve this for x, then I will have the x-coordinate for the x-intercept. So -4, so -4 equals 2x. Divide by 2, so we get x equals -2. So the x-intercept is -2, 0, which is right here. And you can see that it's on the line. I mean, it should be. I kind of graphed it wonky, but it is on the line. Okay, so x-intercept, you always plug in 0. Y-intercept for y. Y-intercept, you plug in 0 for x. Very easy to calculate the intercepts for a problem like that. Number 9, graph the absolute value function, plot 5 ordered pairs. Okay, and we need to describe the transformation as well. Okay, so that's fine. I'm going to graph this using transformations only. So the vertex is going to come from these two. -1 means the x-coordinate is +1, and -3 means the y-coordinate is -3. So the vertex is 1, -3. The vertex is right here. Now, I said I was going to graph this using the transformations to describe the transformations from the parent graph. Okay, well, the -1 inside here tells me that it's a shift to the right by 1 unit. The -3 tells me on the outside that it's a shift down by 3 units. Okay, and we can see the vertex has moved from 0, 0 down to 1, -3. So everything else is going to change as well. So if we look at where the points usually are for the parent function, the points are like this, okay, making this V shape. I need to move all of the points down 1 and right 3. Okay, so down 3, right 1, down 3, right 1, 1, 2, 3, 1, so right here. This one, 1, 2, 3, 1 is right here. This one, 1, 2, 3, 1 is right here. Okay, so my shape is like this. This is my graph, my V shape for my absolute value function that I'm looking at for number 9. My domain, of course, is all real numbers. That's always going to be the case for any of these, all real numbers, because you can see that on the x-axis, there's always going to be a point on the graph. However, that's not true for the y-axis. If we look at the y-axis, there's actually a minimum that we get to. It's right here. The graph goes up from this point, but there's nothing below this. That is actually at -3. and this is above -3. So we would say the range is the y values greater than or equal to -3, because this thing starts at -3 and extends upwards. So greater than or equal to -3. Hello. Oh, nice, last one. Okay, so for the number 10, we're graphing this linear inequality. So we graph this the same way that we do just a regular line. It's just we have to worry about the symbol here when we graph it. So the y-intercept here is 0, 4. The slope is negative, so it's going to be pointing down, -2/1, we could say. But just keep in mind, this will be pointing down. So 0, 4 is right here. We go down 2 and over 1, like right here. Or we could go up 2 and over 1, as long as our graph points down. Now the symbol, this one, we have it like this. That tells us that it's a solid boundary. So let me do a solid boundary like this. And then it also says that it's shaded above because it's opening to the left, it's opening to the y. So it's shaded above. So the solutions are up here. Okay, so everything on the line is a solution. Everything above the line is a solution. So this would be our solution set.